Hello everyone, my name is Vlad and welcome to the third episode of Decentraland tutorials, and today we'll talk about systems and the movement of the entities. We'll start with the rotor system, which was a part of the default scene. Let's have a look how does it work. So this is our rotor system and I just uncommented and nothing else. Here we have my two entities, and as you can see both of them moving. Rotator system. In the first line we have here group. We create a group which is engine get component group transform, which means it gets every entity which contains transform component, and if your entity is in a scene, then most likely it has a transform component. Basically what it means, get all the entities in a scene. Update function, which takes dt delta time parameter. It's basically a loop for each frame, and for each frame we can make changes to our entities. Here for example we go through all the entities, get our current entity, and using its transform to rotate our entity. Here we rotate over the y-axis. You can see this vector 3 up is 0 on x-axis, 1 on y-axis, and 0 on z-axis. And this is amount we rotate it to. So this dt, delta time, it's used to make your movement smooth and independent from frames per second, FPS. So even if your frames per second are variable, your movement should still be smooth. And here we're adding our rotator system into our engine. If you miss this step, your system is not gonna work. As you can see, both our items, both our entities are rotating. Box is rotated along the y-axis and the laptop appears to be rotating along some other axis, but that is because we have some rotation we applied to our laptop itself. So if we remove this rotation over the laptop, you can see that it is being rotated along the y-axis. So, okay, that is our rotator system, and that is pretty straightforward. So what if you want to do something else? For example, we want to move our object, our entity. Well, first of all, we have a great documentation. So we have Decentraland documentation, and if we search for move entities, we have all the different types for the movement. So movement, rotation, this one rotate over a pivot point is really interesting because we create a pivot entity and we set this pivot entity as a parent for our entity and rotate around it. This is really useful if you want to animate doors, for example. So what else? Lerp data. Linear interpolation, if you want to move between 2 points, that one is really interesting and really useful. Let's do this one. What we can do, we can actually just copy it and replace our, we don't need this rotate system anymore, and add it to the system. So we are going to work with box entity, and what do we need now is to add this origin, target, and fraction variables parameters to our box. So if you look at the documentation, we can see that we have this system, and here our entity is created. But then we add this lerp data, which is a custom component with different parameters. Let's do it for our entity. So we have box, and for this box we add component, new lerp data, box get component lerp data origin, which is same as initial position. So we are using vector 3 1 and the box get component lerp data target position, which is new vector 3, and let's move it closer to our laptop. So let's move it to 7 1 7. So and now when we open our scene, it should start to move from its initial position to our laptop, close to our laptop. Yeah, as you can see, it started to move. What we can do, we can start this movement on click event. So we add box, add component, and we are adding a new on pointer down event. Here we create a callback. Let's create a message or text, click to move. And let's move this one this way. And now, as you can see, it is static, but as soon as we click, it starts to move. What we might want to do is to repeat this movement on the next click, but it doesn't work for two reasons. First of all, we are checking this fraction. So we are moving our object using this fraction. So from 0 to 1. And right now it is equal or more than 1. So we need to reset this fraction. So what we're doing is box get component lerp data fraction equal 0. But this one is not gonna work as well, and I will explain you why. That is DevTools console, and as soon as we'll click on the entity again, we'll see this error that lerp data is already present in entity, and that is because I'm trying to add component on each click, which is obviously wrong. The easiest way is to add component or replace. Also, we see a lot of these errors, cannot get component lerp data, and that is we can fix with or no. It's trying to get this component on this line. So if we make additional check that if lerp and like this. So right now we shouldn't have any errors regarding this component. So this is reloaded, and let's start the movement. And we can start again. So now it works. That is a simple. So that is a simple move from one point to another, from point A to point B. Let's go through the system and look what does it do. So first of all, this one is a lerp data class we create. It has origin point, target point, and fraction number. We create this class as a component, so we can assign this component to our entity. As soon as we assigned it, we can get this component and change the values of it. Really nice way to organize your data. In the system itself, lerp move, we have this loop, update loop, with the delta time as parameter. So what do we do here? As in the previous system, rotator system, we have this, we're getting transform straight away, as well as we are getting all the data from this custom component, which we added on click. We added this or null and this check just to avoid any errors before this component is added to our box. So if condition for data and our fraction is satisfied. If a fraction less than 0, we use our position to move our entity. We are using ler function which calculate position between origin and target point using this fraction again. And we update this fraction. We divide delta time by 6. Here you can adjust the speed of the movement, but we're using this delta time to make the movement smooth, independent of the FPS. And of course, we are adding the system to the engine so it can start to work. If you forgot to add it, it's not gonna work. So keep an eye on it. So this one is pretty straightforward, and we just took it and copy pasted it from a documentation. But what if you want to make something more interesting? For example, we want to take this box and make it float in the air, so slowly up and down, as you can see in some games. I knew that I need to use sine function, but it still took me a time to figure out the right equation for that. So let's do it right now. You don't really need this additional component class, and let's make it from the scratch. So we create a new class, call it float move, which implements iSystem, and we have a update function with delta time. What? And again, we are using transform of the box entity. Here we need a few variables. We need magnitude. Let's put it 10. We need height. Let's put it 1. And we need our fraction, which we can just create as a global variable, set it to 0. We can update it straight away, it doesn't really matter. And this fraction is sorry, it's not const, it's we need to change the values, and this fraction is actually our speed. As we want our entity to float, we need to change y values, and for that we're using our transform position y, and we update this value, and the equation is like this: height plus math dot sine, where we multiply whoa, what have I done? Where we multiply math dot pi multiplied by fraction and divided by magnitude. Of course, we add our float move to our system, and we do not need this on click event because we want it to run straight away and indefinitely. And you can see that it does move. Yeah, it moves, but really slowly. Let's make it faster. Let's put it 6. 6 should be faster. So yeah, you can see that it's moving up and down. Let's put it even faster. So yeah, you can see that it's moving up and down as we wanted. And to spice it up, we can actually add additional rotation. So we can use transform, rotate, we can use vector 3 up to rotate it along y-axis and not just put 1. So you can see it is rotated and also float in the air up and down as we wanted. These systems, they might be intimidating in the beginning, but as soon as you try it, as soon as you look at the documentation and try a couple of more different examples here, you start to understand the principles, how it works, and it's going to be much easier to understand and not as scary as the very first time. So try it, play with it, and if you have any questions, please comment below. I'll try to help as much as I can. I hope it was helpful. Thank you for watching and see you next time.